Welcome back to page 2. On this page you'll notice that there are 5 different equations, and what we're going to do is analyze these equations to find all this information: the center, the vertices and the co-vertices, the lengths of your major and your minor axis, and the location of your foci. I know I totally skipped over, and on purpose I skipped over mentioning, because I didn't want to make that first video too long, I skipped over mentioning how do we translate all of these ellipse graphs. Now we've done it for circles, and we've done it all year for other different formulas, including our parabolas in this chapter, is that you'll notice equations 1 and 2 are very different than 3 and 4, and we're not even going to talk about 5 yet. But if we start with question number 4, what I'm going to do is either you can pause your video, but please identify in your own mind number 4. Where do you think the center is of the ellipse of number 4? Did you say -1, +1? And if you did, you are correct. Going backwards, let's go to number 3. It does not shift in the x direction, but in the y direction it shifts down 2. 0, -2. What would the centers of 1 and 2 become? They would be both 0, 0. Alright, instead of going through 4 equations at once, let's stick to question number 1 and finish it. But you now know that just like our circles and parabolas and other graphs, we can shift our ellipses left, right, and up and down by adding constants inside of the parentheses on your squared x and square y terms. Alright, let's keep going. So back to question number 1. The first thing I want to determine is our value of a is the larger value. So 144 is a squared, so a would equal 12. Your major axis would be 24, or 2 times 12. Our minor axis, if b squared is 64, b equals 8, and 2 times b is 16, that is your minor axis length. We also want to determine that this is going to be what type of ellipse? An ellipse that is wider. So it's going to look wider compared to how tall it is. So now that we've identified the center, and we know that 12 units to the right of the center and 12 units to the left of the center are your vertices, what is 12 units to the right and left of 0? 12 units to the left, 12 units to the right. The y-coordinate does not change because the vertices are horizontally located with respect to each other. They don't go up or down. They're on that major axis, so their y-coordinates are the same as your center. Your co-vertices will go 8 above and below the center. So we're going to add 8 to your y-coordinate. The x-coordinate isn't going to change, so 0 plus 8, 0 minus 8. That would just, of course, be the y-coordinate, and your x-coordinates do not change. Let's go into your foci. What we're going to do is use your formula. C squared equals a squared minus b squared. Again, how do I know which one's a squared? We want the difference of those two values to be positive. So c squared equals 144 minus 64. Doing some little subtraction, we get that c squared equals 80. Square root it. I will do plus or minus this time. Now the square root of 80 does simplify. What perfect square goes into 80? Well, I know 4 goes in it, but also so does 16. 16 goes in 5 times, so this is 4 root 5. Now where are the foci? They are to the right and to the left of the center. Not all the way to right and left, but somewhere here and somewhere there. So we're going to add 4 root 5 and subtract 4 root 5 to the x-coordinate of the vertex. So 0 plus 4 root 5, comma 0. 0 minus 4 root 5, comma 0. And these are the location of the two foci. Those are internal inside of the ellipse. Alright, let's continue on with question 2. Going across to question 2. This is the larger value. That makes it a squared. That makes the value of a equals 20. So if a equals 20, then 2 times a is the length of your major axis, or 40 units across. Maybe I should put units down here because it's length. Alright, the square root of 175 is the length of, or the value of b, and double that is 2 times the square root of 175. 175 needs to be simplified. If I know that 175 divides by 25, I can do our little factor tree sort of thing and get that this is 5 root 7. So I know 5 root 7 is the length of b, and double that would be 10 root 7 units would be the length of the whole minor axis. Okay? Next, where are the vertices? Notice that the larger numbers underneath the x, we have another ellipse that's going to be wider. So if our center is 0, 0, we're going to go 20 in each direction, left and right. Where am I getting 20 from? Again, it's the square root of the a squared. 20 to the right of 0 and 20 to the left. So 0 plus or minus 20, comma 0. So if I go left, if I go right, these are your vertices. To get the co-vertices, we got to go up, we got to go down. We got to go up and down. That would be 5 root 7 units. So 5 root 7 units added and subtracted to 0. So 0 plus 5 root 7 and 0 minus 5 root 7 would be negative 5 root 7. And these would be the location of your two co-vertices. Let's find the location of the foci. A squared minus b squared equals c squared. So I'll do c squared equals 400 minus 175. C squared equals, let's see, if I had 25, that's 200, so 225. Oh, that's a perfect square. So c equals plus or minus 15. We're going to add, go 15 to the right and 15 to the left. Now these are 20 to the right and 20 to the left would be the vertices. So they'd be closer to the vertices, but still the foci are internal. So let's go 15 to the left and let's go 15 to the right from your center. Alright, that takes care of your first 4 exercises. Let's slide this up a little bit and let's take a look at questions 3 and 4. And I see that number 5 is looming there at the bottom. Alright, let's keep going. So we have already located the length, we've already located the location of our center, 0, negative 2. Now we got to do the length of the minor axis and the major axis. Alright, compare these numbers. 64 is larger. That makes it a squared. That makes the value of a length of 8. And 2 times that, 16 units, is the length of the major axis. The square root of b squared would be 4. So that means 4 times 2 would be 8 units. Would be the length of the minor axis. Now, for the 3rd time in a row, we have an ellipse that's wider instead of taller. So our center is 0, negative 2. So our vertices would go left and right, and our co-vertices would be up and down. Let's go 8 units away, left and right. So it's going to be 0 plus 8 and 0 minus 8. So 0 minus 8 is negative 8, and the y-coordinate does not change. 0 plus 8 and the y-coordinate doesn't change. These are your two vertices. This would be our center is 0, negative 2. Go 8 to the right. That's 8, negative 2. Go 8 to the left. That's negative 8, negative 2. Okay. Now we're going to go up and we're going to go down. This is already below an axis. So when we go up and down, let's take a look at what happens. We have 4 is the value of b. We're going to add and subtract 4 from negative 2, but the x-coordinate won't change. Let's add 4 to negative 2. Let's subtract 4 to negative 2. So these are the locations of your co-vertices. So we have a picture here. If this were the coordinate plane, this would be 0, 2. This would be 0, negative 6. This is 0, negative 2, our center. So a positive 8, negative 2, a negative 8, negative 2. And we'd form this little ellipse shape. Now that I've sort of have a graph, I can actually sketch a better picture. I do a lot better when I have a coordinate plane to sketch my graphs. Finally, let's finish up our location for our foci. We're going to subtract 64 minus 16. 64 minus 16 gives us 48. So c squared equals 48. Not a perfect square, but a perfect square goes in it. 16 goes in 3 times. I don't know why I wrote a 5. Let's try that again. So this is 4 root 3. We want to add and subtract 4 root 3 to the x direction, to the x coordinate. So 0 plus 4 root 3 and 0 minus 4 root 3. Now what's the y coordinate of those foci? They would go almost 7 units to the right and almost 7 units to the left. How do I know it's almost 7 units? Well, this is almost 49. So it's pretty close. Actually, if I were making a better sketch, those foci would be really close to the vertices, but still internal. The y-coordinate of those foci, they don't change. Alright, I'm going to continue with number 4. Maybe I'll do number 5 in a separate video. So what's the length of our major axis? Okay, so this is the larger number, 150. So that makes a squared equals to 150. What would a equal? That would be 5 root 6. The value of a is 5 root 6. So double that would be 10 root 6 units is the length of the major axis. Okay? What's the minor axis? It would be 6. So the value of b equals 6. So 6 times 2 would be 12 units is the length of the minor axis. Where are the vertices? Now the vertices will be 5 root 6 more and less than the center. But which coordinate? For the first time, the larger number is underneath our y squared. So if we were making an ellipse, this is a taller ellipse. Imagining this is your center, we're going to add 5 root 6 to the y coordinate of your center. So the vertices, their x coordinates won't change. What about their y coordinates? It would be positive 1 plus 5 root 6 and positive 1 minus 5 root 6. Those are the best simplified exact coordinates for the vertices. How about our co-vertices? Our co-vertices will go left and go right. Go 6 left and 6 right. That means we're going to affect the x coordinate, not the y coordinate. 6 left and 6 to the right. So negative 7, 1 and 5, 1. Okay, last, let's finish up our foci. Our foci would be c squared equals a squared minus b squared. So c squared equals 150 minus 36. That looks like 114 to me. So c equals plus or minus the square root of 114. If I try to factor 114, let's see, 4, 5, 6, so it's even, it divides by 2. If I add the digits 1 and 1 and 4, that makes 6, which means it's divisible by 3, which means it's divisible by 6. 6 goes in 19 times. How do I know that? Like 6 times 20 would be 120. This is 6 less than that. So it would be 6 times 19 or 2 times 3 times 19. No perfect square simplifies. We're just going to do what? We're going to just take this, and this is our exact most expression for that length of c. So the foci would be root 114 up and root 114 down. So you're looking at more than 10, less than 11 units away. We're going to add it to their y coordinate, negative 1, and the y coordinate would be 1 plus root 114, negative 1, 1 minus square root of 114. These would be the location of your two foci. I'm going to stop here and explain number 5 next.